Tokyo, a bustling metropolis, faces significant challenges due to its vulnerability to flooding, exacerbated by heavy rainfall and its geographical location. To combat this persistent threat, the city has implemented an extraordinary engineering solution: the underground flood control system, known as the Metropolitan Area Outer Underground Discharge Channel. Japan's cities don't fear floods. Here's the genius engineering behind it. This innovative project, completed in 2006, showcases the remarkable ingenuity of Japanese engineering, designed to manage and redirect excess rainwater away from urban areas. Spanning over 6.3 kilometers, this colossal system features massive underground tunnels and reservoirs, capable of holding up to 1.4 million cubic meters of water. The historical context of this endeavor is equally compelling, as it arose from the devastating floods of the 1950s and 1960s that prompted urgent action. By transforming the way Tokyo addresses flooding, this project not only protects the city but also stands as a testament to human creativity and resilience in the face of nature's challenges, making it a fascinating topic for exploration. Tokyo's geographical challenges are deeply rooted in its location on a floodplain, which significantly contributes to its susceptibility to flooding. Situated at the confluence of several rivers and near Tokyo Bay, the city is prone to heavy rainfall and storm surges, making it vulnerable to inundation. Historical records reveal that flooding has been a persistent issue since the 1600s, with devastating events documented throughout the centuries, including the catastrophic floods of 1910 and 1958 that caused widespread destruction and loss of life. As Tokyo has evolved into a sprawling urban center, the impact of urbanization has further exacerbated flood risks. The extensive development of infrastructure, coupled with the loss of natural drainage systems, has reduced the land's ability to absorb rainfall, leading to increased runoff and higher flood levels. This combination of geographical challenges and historical flooding issues underscores the urgent need for effective flood management solutions to protect the city and its residents from future disasters. The Tokyo Flood Tunnels Project, officially known as the Metropolitan Area Outer Underground Discharge Channel, emerged from a critical decision-making process aimed at addressing the city's chronic flooding issues. Following devastating floods in the mid-20th century, city planners and engineers recognized the urgent need for a comprehensive solution to manage excess water effectively. The project's primary objectives are to divert and store stormwater, thereby preventing flooding in urban areas and protecting lives and property. Spanning over 6.3 kilometers, this ambitious undertaking features a series of massive underground tunnels and reservoirs designed to handle an impressive capacity of 1.4 million cubic meters of water. The scale and complexity of the engineering involved are truly remarkable, as the project required advanced technology and innovative design to navigate Tokyo's dense urban landscape. By transforming how the city manages stormwater, the flood tunnels not only enhance flood resilience but also stand as a testament to human ingenuity in the face of environmental challenges. The Tokyo Flood Control System boasts several key engineering features that work in harmony to manage stormwater effectively. One of the standout components is the pressure-adjusting water tank, designed to regulate water flow and pressure within the system. This tank plays a crucial role in ensuring that excess water is managed smoothly, preventing potential surges that could overwhelm the infrastructure. The tunnels themselves are impressive, reaching depths of up to 50 meters and spanning over 6.3 kilometers, with a capacity to hold approximately 1.4 million cubic meters of water. This extensive network allows for the efficient diversion of stormwater away from vulnerable urban areas. Complementing these features is the highly efficient pump system, which is vital for flood management. Capable of moving vast quantities of water quickly, the pumps ensure that the collected stormwater is redirected to the river system or storage facilities, significantly reducing the risk of flooding during heavy rainfall events. Together, these engineering marvels exemplify Tokyo's commitment to innovative flood management solutions. The operational process of Tokyo's flood control system is a meticulously designed sequence that effectively manages stormwater during heavy rainfall. When intense rain occurs, excess water is diverted into the underground tunnels through strategically placed inlets located throughout the city. As the rainwater flows into the system, it travels through the expansive network of tunnels, designed to accommodate large volumes of water while minimizing the risk of overflow. The water is then directed toward the pressure-adjusting water tank, which regulates flow and pressure, ensuring a smooth transition through the system. Once conditions permit, the collected water is gradually released back into the river system or storage facilities, preventing sudden surges that could lead to flooding. The impact of the sophisticated system on flood damage reduction in Tokyo has been significant, as it has dramatically decreased the frequency and severity of flooding events. By effectively managing stormwater, the flood control system protects lives, property, and infrastructure, showcasing the city's commitment to resilience against natural disasters. The flood tunnels in Tokyo have far-reaching implications for the city's residents, significantly enhancing their quality of life. One of the most notable benefits is the estimated economic savings resulting from reduced flood damage. By effectively managing stormwater, the system has minimized the financial losses associated with flooding, allowing businesses and homeowners to thrive without the constant threat of inundation. Additionally, the flood control system provides a profound sense of security to residents living in flood-prone areas. Knowing that there is a robust infrastructure in place to handle heavy rainfall alleviates anxiety and fosters community resilience. This newfound confidence has also positively influenced urban planning and development, as city planners can now focus on sustainable growth without the looming fear of flooding. The flood tunnels have paved the way for more ambitious construction projects and revitalization efforts, ultimately contributing to a more vibrant and economically stable Tokyo. In essence, the flood control system has transformed the urban landscape, enhancing both safety and prosperity for its residents. Despite its impressive achievements, Tokyo's flood control project has faced several challenges and criticisms. One of the primary concerns revolves around the high construction and maintenance costs associated with the system. The initial investment was substantial, and ongoing expenses for upkeep and operation continue to strain municipal budgets, raising questions about long-term financial sustainability. Additionally, there are growing concerns regarding the environmental impact of the project. Critics argue that the extensive underground infrastructure may disrupt local ecosystems and alter natural water flow patterns, potentially leading to unforeseen consequences. Furthermore, as climate change intensifies, the need for future-proofing the flood control system has become increasingly urgent. With predictions of more extreme weather events and rising sea levels, experts emphasize the importance of adapting the infrastructure to meet these evolving challenges. Addressing these criticisms is essential for ensuring that the flood control project remains effective and environmentally responsible, ultimately safeguarding Tokyo's residents against the increasing threat of flooding in a changing climate. As Tokyo continues to address its flood management challenges, potential enhancements and expansions of the flood control system are being explored. One promising avenue is the integration of artificial intelligence, AI, and Internet of Things, IoT technologies, which can significantly improve real-time monitoring and predictive analytics for flood events. By utilizing smart sensors and data analytics, the system can better anticipate heavy rainfall and optimize water flow management, enhancing overall efficiency. Additionally, there are plans to expand the tunnel network to cover more areas, further reducing flood risks in vulnerable neighborhoods and ensuring comprehensive protection across the city. This expansion aims to create a more interconnected system that can handle increased stormwater runoff. Furthermore, ongoing research is focused on making the flood control system more environmentally friendly. Innovations such as green infrastructure, which incorporates natural elements to manage stormwater, are being considered to minimize ecological disruption while enhancing the system's resilience. These enhancements will not only bolster flood management, but also promote sustainability in urban development. Tokyo's flood control system serves as a vital reference point for addressing global flood risks, particularly in light of recent flooding events in regions like Florida, where hurricanes have caused devastating inundation. These incidents highlight the urgent need for effective flood management strategies worldwide. The principles behind Tokyo system, such as advanced engineering, real-time monitoring, and proactive water management, could be adapted for other flood-prone areas, offering a blueprint for resilience. For instance, cities facing similar challenges could implement underground tunnels and reservoirs tailored to their specific geographical and climatic conditions.